Hello everyone, welcome to Weather Forecasting 101. This is Mr. Plucker. Today's May 5th, 2015. Severe weather season is upon us. Each year in the United States, thousands of professional and amateur storm chasers take to the U.S. plains to chase, photograph, and research severe weather. Before any of them do this, though, they need a basic understanding of weather. Today we'll focus on two different weather topics that'll help you gain a basic understanding of weather. The first topic for discussion today will be the different weather symbols used by weathermen on maps. You'll have the chance to see how each of these symbols is used on a weather map. We'll focus on high and low pressure, fronts, air masses, precipitation types, winds, and severe weather. Secondly, you'll have a chance to make your own weather forecast using these symbols on your own map. But before we do all that, we'll have a chance to watch Cameron Moreland from NBC 26 in Green Bay as he gives his weather report. You'll then create your own weather report based on the weather information you'll gather. You'll use the symbols that are common to weather maps to create your own map and present your report to the class. There are a number of different air masses that affect our region here in North America. First of all, you see these symbols on the map, these abbreviations rather. The ones that say M in front of them stand for maritime. Those are air masses that will form over an ocean. Those tend to be moist air masses. Near the poles, the maritime polar that you see here, the MP, is going to be cool and moist, and maritime tropical is going to be warm and moist. And then you have the C's in front of these two. Again, you see the P and the T for polar and tropical. These are continental polar and continental tropical. And once in a while, the continental Arctic air mass that forms way up over the North Pole here can make its way down and affect us as well, usually in the cold of winter. You already see here drawn on the map some of the symbols for cold fronts, especially the blue line here, marked with the blue triangles on them. It's kind of depicting here where there can be boundaries between the two air masses. Down here at the bottom then you see all four of the types of fronts that are possible. First off, you have the cold front here, where a cold air mass is pushing in toward the warm air mass. That cold air mass, as it pushes in, tends to cause a lift here in the warm air and causes clouds to form. The next one is the warm front. You have a warm air mass here, and the arrows drawn there, as it's riding up over the cold air mass, causing some clouds to form here. Usually you get some light precipitation from warm fronts. The third kind is a stationary front, and here you can see that the warm air mass is pushing, and so is the cold air mass, and really neither of them is moving the other one, and so what ends up happening is the air that meets in the middle here kind of tends to rise, and you tend to get lots of stormy weather in these situations. And finally, the occluded front. This front doesn't occur very often, but here is where you have a cold air mass that sort of takes over another cold air mass and lifts an entire warm front up. So really what it is a cold front that runs into a warm front, and it takes this warm air mass that was here, and it just lifts the entire air mass high up into the sky. So occluded fronts generally are going to occur in stormy situations. So here you have your four main types of fronts. Now you see the cold front drawn on the map here with the blue lines and the blue triangles there that come off of it. A warm front would then be drawn with red lines, and instead of the triangles you'd have little half circles drawn on the warm front. Now these half circles and these triangles do point the direction that the air is moving behind the front. So there you would have the air moving up from the south, and here you would have the air moving down from the north, as indicated by the arrows here. A stationary front is going to look somewhat like this then. You have some of it be a warm front, and then another portion of it be the cold front, like that. And then occluded fronts, they actually draw these with purple lines. There would be like an occluded front here, and what they do there is they'll draw this half circle and then a triangle right next to it. And so here are your four main types of fronts, and how they form, and how they would be drawn on weather maps. Here we see how winds flow with relation to high and low pressure systems. You see this high pressure system right here marked with the blue H, and then the low with the red L here. These numbers stand for the atmospheric pressure around each one of these, and so here it would be 1012 millibars of pressure is how we measure that, 1008, 1004. And then over here you see the pressure drops to the center of the low with 948. So the pressure in this high is probably about 1015, or 984, excuse me, about 1015, and probably about 980 in the middle of the low. Now you'll notice that these arrows will be flowing in a clockwise direction around and away from the center of the high pressure. Also, you'll notice that they don't flow right along these lines of equal pressure. These lines of equal pressure are called isobars. An isobar, iso means the same, and so it's where the same pressure readings are found. And these lines, you can see how they flow sort of across the grain a little bit there. Oops, let me get my drawing tool turned on. There we go. How they flow sort of across the grain here of the isobars a little bit. And so if I were to take just this arrow in particular, and I'm going to draw the path of a particle of wind, it would follow probably something like this as it would make its way away from the high pressure system, out from the middle, the center of it rather, in a clockwise way, and then once it starts to approach the low pressure, it would start to move in a counterclockwise way toward the middle of the low pressure. Now it's a difference in pressure then that causes these winds. If you picture this high pressure like a mountain and this low pressure like a valley, naturally the air is going to flow from the high region to the low region, just like if you would, let's say, have a boulder or a rock at the top of a high hill, and you would push it down the hill, it would just flow down the hill, or it would roll down the hill. But because the earth is spinning, the air doesn't flow in these perfectly straight lines from high to low pressure. Instead, this is how we get the clockwise rotation around a high pressure, and then a counterclockwise around a low pressure. There are really 5 types of precipitation that are going to affect our weather here in the United States. Here on the drawing, on the diagram here, we see a cloud deck here that has precipitation falling from it. Now, generally, when you have warm air all the way from the ground up into the cloud, that's where you're just going to get your rain. That's pretty normal, especially in the summer months in North America. What can happen then is sometimes a warm layer of air can make its way up toward the base of the clouds, but a cool layer of air can still remain in place down near the ground. So as the rain falls through the warm air, it's a liquid like normal, but it doesn't have enough time to freeze. And so it's still a liquid form of rain until it hits the ground. Now the ground cools off faster than the air above it. So the ground might be, let's say, 31 degrees, which is of course below freezing, and as that liquid rain hits the ground, it freezes on contact. And so that's how freezing rain forms. Next is sleet. Now you'll notice here the rain has a little bit more time to cool off. And so what happens is the rain, instead of staying a liquid all the way to the ground, it's a liquid until maybe a few hundred feet above the ground or more, and then those raindrops will actually freeze into little pellets or droplets of ice. And so what sleet really is just a raindrop that has frozen into a ball of ice. Snow occurs when now, instead of the warm air going from the cloud base to the ground, it's air that's below freezing. So the air all the way up into the cloud is below 32 degrees Fahrenheit, and as that snow falls out of the cloud, it stays snow all the way until it reaches the ground. The 5th type of precipitation is hail. And I'll just blow this up here for us to get a better view of that. Hail formation is completely different from all these other types of precipitation in that it's the only one that, besides rain of course, that forms in thunderstorms. So what happens in a thunderstorm is this red arrow is meant to show what's called an updraft. So the air moves up into a thunderstorm, and you have these raindrops that are being pulled into an updraft, and there's a freezing level partway up the thunderstorm. And so as the raindrops get above that level of freezing, they freeze into chunks of ice or balls of ice. And then they get pulled up higher and higher, and pretty soon they get too heavy and they start to fall. But the updraft, if it's strong enough, the updraft continues to push them up. and eventually layers of ice will form on the original ball of ice. As it gets heavier and heavier, if the updraft is strong enough, it'll grow even larger and larger. But eventually, gravity wins. And so the ice chunk now is large enough where it's going to finally fall out of the thunderstorm. Generally, hailstones will form kind of near the back end of a thunderstorm. You don't typically get them in the front part of the thunderstorm. You can, but not very typically. So they'll form in the middle part of the storm, and as the storm passes by, the hailstones will finally start to fall out, generally the back of the thunderstorm. Some of the hailstones can grow to be rather large, size of baseballs or softballs, and do quite a bit of damage. Here we'll have a quick summary of some of the major types of severe weather that can occur in our country. First of all, we see a drought condition. You can see the soil here is very parched, it's very dry, lots of cracks in the soil showing that there really isn't much water here. There's a good chance that this actually may have once been a riverbed where water would have probably been flowing pretty freely. Over here then you have blizzard conditions. You can see definitely lots of snow has fallen, but what you want to notice here is how much snow is being blown around by the wind. That's really what's going to cause a blizzard. It's the high winds along with the snow that falls. Here's a satellite picture of Hurricane Katrina before it made landfall in Louisiana. You can see this hurricane, it definitely has an eye here in the center, and it has this typical spiral bands of a hurricane. Hurricanes, of course, have to be over 74 miles an hour for their winds in order to be classified as a hurricane. Over here we have tornadoes and hail. Now those are two of the major causes of damage from thunderstorms, severe thunderstorms. As I mentioned just a moment ago, hail can be rather large, and here you see these hailstones measuring pretty much the size of this baseball right here. This tornado generally looks like a little bit of a weaker one, but don't let size fool you. Sometimes some of the smaller ones can be the strong ones. But either way, both of these hail and tornadoes can and do often come from thunderstorms. And finally, flooding. Flooding really isn't only from one type of severe weather. Hurricanes almost always cause flooding where they reach land and they drop just tons of inches of rain, sometimes up to 2 feet of rain. Severe thunderstorms can also cause flooding, usually not of this level, but they can still cause flooding in areas as well. So we have our drought, blizzard, hurricanes, tornadoes, and thunderstorms with hail, as well as flooding as our types of severe weather. So here's a current surface weather map of the United States. One of the main features I'd like to point out right away is the stationary front that you see that stretches all the way from the northeast through the lower Great Lakes and the central plains of the United States. You can see clearly here the pink or red with the half circles drawn here on these warm front sections of the stationary front, and then the cold front has the blue with the triangles. Here's a pretty clear one right there in Iowa. One thing I do want to point out is that it seems as though the stationary front is starting to move a little bit. As I mentioned earlier, remember with stationary fronts you're going to tend to have the cooler air, in this case coming out of this high pressure, trying to push down a cold front from the north. And there's a high pressure right off the coast here of the southeast North America, or southeast U.S. rather. So we'll just draw that in. It's probably a little bit off the screen here, but we'll put it here for now. As the winds are moving a clockwise way away from this, they're going to try to push north. Well, of course, once they do that, these winds have nowhere to go because neither of them moves. So if you may remember from just a few moments ago, I showed you how when those air masses meet each other, the winds are going to the air is going to rise rather, and you'll get precipitation, as you can see here in the lower Great Lakes, over into Wisconsin and Minnesota, and then a little bit out here in New York and the Northeast. The main area, though, where the precipitation is actually found now is out here in the Great Plains. So you can see a large area of rain and thunderstorms here. You can see some severe weather, actually a tornado watch just over here inside this red box. So near this watch box, you're going to find some thunderstorms that probably have some tornadoes. In fact, this little red one right here, that probably has some tornadoes in it. or has had a history of tornadoes, just judging by its size and where it's located. These yellow dash lines are really called troughs. They're not really fronts necessarily. They kind of act like a front as they're a triggering point for thunderstorms or precipitation to develop. If you recall just a moment ago, I talked about how low pressure systems are like valleys. This is more of a shallow valley, not so much of a deep valley. I think of it as almost like a ripple. And so instead of it being a deep valley that one of these main low pressure systems are that are found along the stationary front, this is more of a shallow valley, but enough where it's going to be able to kick off some of the precipitation that you see here. You can also see on this map a rather large area of clouds. I'm going to try to outline here as best as I can. That is associated with the stationary front that moves across the U.S. here, or that lies across the U.S. So as you can see, there's a rather large area of the country that's affected by this storm system. Just a moment ago I mentioned this warm front. What seems to be happening here is the warm air surge seems to be pushing, and finally this warm front seems to be winning out over the cooler air up here. As you can see, this large bow this large bow in the warm front out of the stationary front rather seems to be indicating that pretty clearly. The rest of the stationary front tends to look kind of wobbly and weak, whereas this is kind of an area of strength where you can see the front getting pushed out. You do see some of the specific pressure readings on here. This particular high over the Lake Superior, that looks like about 1,026 millibars. Here's 1,025. And then there are a bunch of low pressures all over in the Rockies here and along the stationary front. In particular, here's a 1,019. A little bit lower here, another 1,019 in the northeast. And 1,003 down here, and the reason that, and another 1,003 right here too, the reason that we're probably seeing a little more precipitation with near these low pressure systems is because they are a little bit stronger. You see the lower the reading, the stronger the low pressure, of course. So what you end up with is having these areas of weaker low pressure, and so you see some scattered showers, maybe a thunderstorm or two here. But it's out in the plains, and from Nebraska down to Texas, where you actually are going to see the stronger storms because the low pressures are stronger. Alright, so here is a current weather map that you can use to make your forecast. In just a moment here, we're going to watch Cameron Moreland give his forecast on NBC 26. And you know what, before I go, I just noticed this up here. There's a little bit of an occluded front right here, just north of Montana. You can see the purple shading here, the triangle here, and then the half circle there. So there's a warm front that seems to be sort of connected right here to this low pressure system, and it looks like this cold front right here has kind of overtaken that warm front, and so it's made this little occluded front right there. Alright, so as I just mentioned, we're done looking at the current surface map. I think what we'll do now is we'll take a look at Cameron's forecast, and then, like I said, you can model yourself after Cameron a little bit at least. I'll mention it in a few minutes that we don't have necessarily the equipment that he does, but we can certainly do our best with the knowledge that we've learned, and with me guiding you along the way. So now you'll have the opportunity to watch Cameron Moreland from NBC 26 in Green Bay as he delivers his weather report for Northeast Wisconsin.
Chief Meteorologist Cameron Moreland. Well, today was the coolest day of the month, but it is going to warm back up starting tomorrow. Here's a look at your 7-day temperature trend. We're going to see 70s return away from Lake Michigan. Temps will climb into the 80s on Thursday. We'll see mid to upper 70s on Friday, and then some cooler weather will return for Saturday and Sunday. Right now, we are looking at a mixture of 50s and 60s across northeast Wisconsin. There was only one spot that hit 70 today, and that was Shawano, where it's currently 65. Across the south, it's been kind of a gloomy day. Lots of clouds, on and off showers, and much cooler compared to what we've been seeing with high temperatures only in the 50s to around 60 degrees. Right now in Green Bay, after a decent amount of sunshine during the late morning and afternoon, Skies have turned cloudy. The temperature is 64 degrees. In the valley, it is 63 with southeast winds at around 10 to 15 miles per hour. NBC 26 Precision Radar shows that band of showers here across parts of southern Winnebago County, Fond du Lac County, back into Green Lake, Marquette, and Waushara counties. This activity is slowly working off towards the north and dissipating just a bit. Meanwhile, farther to the south, we have a line of showers and thunderstorms now coming together across central Illinois back into central Iowa. We had a cold front move across the area yesterday morning. That cold front stalled out, and now it is beginning to return north as a warm front, and that warm front is going to be making its way into Wisconsin as we head into tomorrow. South of that warm front today, it was feeling like summer with high temperatures in the 80s. North of it, it was cooler, 66 in Green Bay, but still above normal. In fact, we have now had 10 straight days with at or above normal high temperatures, and that warm streak is going to continue. Highs tomorrow away from the lake will be in the 70s, lower to mid-70s across the Fox Valley. West of Lake Winnebago, close to 80. Near Lake Michigan, temperatures will be in the 50s to around 60. And then as we head into Thursday with strong south to southwest winds, high temperatures will be mainly in the lower 80s from about the Fox Valley west. Once again, near Lake Michigan, it will be quite a bit cooler. Precision Cast shows thickening clouds throughout the evening. We'll have a chance for a couple of showers and maybe a rumble of thunder as we head into tomorrow morning. A chance for a few showers and thunderstorms then during the morning as that warm front lifts north across the area, and then sun and clouds by the afternoon with just a slight chance for a shower. The rainfall amounts are not going to be overly impressive, but if you do happen to see a heavier shower or thunderstorm, you could pick up a quick quarter to maybe a half an inch of rain. So your forecast for tonight calls for cloudy skies, a chance for a few showers, and maybe a thunderstorm late. Overnight lows will be near 50. Tomorrow, some morning showers and perhaps a couple of thunderstorms, and then sun and clouds by the afternoon with a slight chance for a shower or a storm. High temperatures will be getting up into the 70s away from Lake Michigan. On Thursday, lots of sunshine, windy and warm, lower 80s. Thursday night into Friday, a chance for a few showers and thunderstorms. Sun and clouds for Friday with that chance of some rain. Highs close to 80. Cooling down on Saturday, lots of clouds, mid-60s, maybe a shower early. A good chance for some showers and perhaps a few thunderstorms. Then Sunday into Monday. Then we cool down again on Tuesday with high temperatures dropping back down into the 50s. And then we warm up as we head towards next weekend. I do want to say a quick hello.
Right, so here you had an opportunity to see a professional meteorologist give his daily forecast for northeast Wisconsin. Obviously, Cameron has quite a bit of computer equipment, things like that we're not going to have access to here. But I will certainly help you along as you make your forecasts as best I can with the limited access to the computer equipment and forecast models that Cameron can use.